Welcome back. So we want to progress from where we left during our last lesson. So I want us to learn about oxidizing properties of chlorine. Now, chlorine is a strong oxidizing agent, and it is capable of oxidizing so many substances because of its strong oxidizing property. Okay. Now, for instance, chlorine is capable of oxidizing iron 2 ions to iron 3 ions, especially when chlorine is bubbled, or when it is bubbled through a solution containing iron 2 ions. For instance, if chlorine is bubbled through a solution like iron 2 sulfate, which contains iron 2 ions, which is pale green in color, a pale blue or a red brown solution will be formed. The red brown solution is due to a formation of iron 3 ions. Okay? So we can say that chlorine is a strong oxidizing agent, and it oxidizes iron 2 ions to iron 3 ions when bubbled through solutions containing iron 2 ions. Oxidation, remember we said, is increase in oxidation number. Therefore, the oxidation number of ion changes from iron 2 to iron 3. Yeah, it changes from iron 2 to iron 3. Therefore, this chlorine here acts as an oxidizing agent. Okay? Now, number 2. As oxidizing agent, chlorine in presence of water. In presence of water, it oxidizes sulfur 4 oxide to sulfuric 6 acid. And itself is reduced to hydrogen chloride or hydrochloric acid. So we are saying that when you actually put chlorine gas in sulfur 4 oxide in presence of water, there will be formation of hydrochloric acid and sulfuric 6 acid. So, in this equation, chlorine acts as an oxidizing agent. So you might ask yourself, how is that possible? If you look the oxidation number of chlorine here, the oxidation number of chlorine there is 0 because it is in combined form. The oxidation number of sulfur here is 4. We shall learn that in form 4, the second chapter. But in sulfuric 6 acid, even the name sulfuric 6 acid, it means the oxidation number of sulfur here is 6. So in sulfur 4 oxide, the oxidation number is 4. The oxidation number of sulfur is 4, while in sulfuric 6 acid, the oxidation number of sulfur is 6. Therefore, the oxidation number of sulfur has changed from 4 to 6. Hence, chlorine has oxidized sulfur in sulfur 4 oxide from it having oxidation number of 4 to 6. Is it clear? Therefore, chlorine is a strong oxidizing agent. That is number 2. Good. As an oxidizing agent again, chlorine is capable of oxidizing hydrogen sulfide. So when it is mixed with hydrogen sulfide gas, chlorine oxidizes hydrogen sulfide to form sulfur solid, and itself is reduced to hydrogen chloride. So the sulfur produced is yellow in color. Okay? So if you have a gas jar which contains, let's say, hydrogen sulfide, and then you add in here chlorine. You add chlorine. Okay? So, this hydrogen sulfide, hydrogen will be removed here. Hence, it will produce now a yellow solid at the bottom here, which is sulfur, and there will be hydrogen chloride gas which is given out. So for that case, chlorine is an oxidizing agent. Apart from that, D, it reacts with ammonia, forming dense white fumes of ammonium chloride. So when chlorine reacts with ammonia, it actually forms white fumes of ammonium chloride. And again, there is also production of nitrogen gas. So chlorine reacts with ammonia, and this forms ammonium chloride. So we can see this reaction occurs in 2 steps. Step 1, chlorine reacts with ammonia to form nitrogen gas and hydrochloric acid. Okay? Then the hydrochloric acid reacts with excess ammonia to form the ammonium chloride. So this ammonium chloride actually is the dense white fumes. Sawa sawa. Good. And last but not least, when bubbled through a solution containing sulfite ions, that is SO3, it is oxidized to sulfate ions. That is, the oxidation number of sulfur changes from 3 to 4. Okay? So the sulfite ion, you can see the number of oxygen in kidogo, and here the sulfate ions, the number of oxygens are more. So we can say chlorine gas, when it is bubbled through a sulfite solution, like iron 2 sulfite, it actually forms iron 2 sulfate instead. Is it clear? So it oxidizes. Oxidation here means addition of oxygen. Oxidation means increase in oxidation number. Good. Thank you very much. So we have actually learned so many concepts about oxidizing properties of chlorine. We have said 1, it oxidizes iron 2 ions to iron 3 ions when bubbled through a solution containing iron 2 ions. And the color of the solution changes from pale green to red brown in color. Pale green is due to presence of iron 2 ions. So when chlorine is bubbled through such solutions, it will actually oxidize the iron 2 ions to iron 3 ions. And then we went ahead and said that in the presence of water, it oxidizes sulfur 4 oxide to sulfuric 6 acid, and itself it is reduced to hydrochloric acid. Okay? Good. We went ahead and said that it oxidizes hydrogen sulfide to form elemental sulfur. Sulfur is the yellow solid. So chlorine here acts as an oxidizing agent. It oxidizes hydrogen sulfide to sulfur. Okay? And itself is reduced to hydrogen chloride gas. Last but not least, we said that chlorine reacts with ammonia to form ammonium chloride. But this reaction, we said, occurs in 2 steps. The first step is that chlorine, first of all, reacts with ammonia to form nitrogen gas and HCl. Then the ammonia gas reacts with HCl to form ammonium chloride, which is the dense white fumes. Good. And last but not least, we say that it is capable of oxidizing sulfite ions to sulfate ions. So when bubbled into a solution containing sulfite ions, they are actually oxidized to sulfate ions. So in terms of oxidation number, we can say the oxidation number of sulfur here changes from 4 to 6. Oxidation number of sulfur here is 6. Hence, there is actually increase in oxidation number. Therefore, it has undergone oxidation. So far, so good. This marks the end of the chemical properties of chlorine. So, before we say bye, I feel it is prudent enough for us to learn about the various uses of chlorine. So, what are some of the uses of chlorine? Good. So, chlorine has got a number of uses. The first one is that chlorine is used as a germicide. So, if you hear the word germicide, what comes in your head? So, chlorine can be used to kill germs. Okay? So, we normally chlorinate our drinking water. This is to ensure that it is safe, and the chlorine, if placed or if added into domestic water, it usually kills the germs. Sawa. So we are saying that as a germicide, chlorine is added to drinking water and in swimming pool to kill disease-causing microorganisms. Okay. Number 2, chlorine is used in the manufacture of plastics such as polyvinyl chloride or PVC. Or the PVC. Number 3, chlorine is used in the manufacture of bleaching agents such as sodium chlorate 1. Chlorine is used in the manufacture of bleaching agent such as sodium chlorate 1. Okay. Also, chlorine is used in the large-scale manufacture of hydrochloric acid. Chlorine is used in the large-scale manufacture of hydrochloric acid. Apart from that, chlorine is used in the manufacture of solvents. Organic solvents like trichloromethane and tetrachloromethane. We use chlorine. In the chlorination process, as we learned in Organic Chem 1, we saw that when you have an alkane and you pass a halogen like a chlorine, okay, the hydrogens will be removed. They will be substituted by the chlorine. Hence, it forms the tetrachloromethane. So that is the basis of producing those organic solvents, which are very, very important. Lastly, or third last, chlorine is used in the manufacture of sodium chlorate 1, which is used in treatment of sewage and as antiseptic and fungicide. Okay? So it is used in the manufacture of sodium chlorate 1. Remember we said that chlorine can react with alkalis. Okay? So when it reacts with alkali at low temperature, we say that it forms sodium chlorate 1. This substance is used in treatment of sewage and as antiseptic. Number 7, chlorine is used in the manufacture of chloroform. Chloroform is very useful as an anesthetic. It is used as an anesthetic and sometimes it is used as preservative. Okay. Number 8, chlorine is used in the manufacture of weed killers such as sodium chloride. So sodium chloride is a weed killer. Last but not least, chlorofluorocarbons or CFCs are used in the manufacture of aerosol propellants. Chlorofluorocarbons are used in the manufacture of aerosol propellants. Okay. Yeah, chlorofluorocarbons are used in the manufacture of aerosol propellants. Some of you here have got perfumes. Okay. The perfumes, for them to move from that can as a spray, inside that particular can, apart from that odor, there are some liquids which enable that particular odor to come out alongside that particular liquid. So those liquids are what we call propellants. They contain the CFCs which are actually short form of chlorofluorocarbons. Good. Now, there is this particular concept which I've deliberately omitted. That is, chlorine is used in the large-scale manufacture of hydrochloric acid. Okay, so we use chlorine in the manufacture of hydrochloric acid, as we shall see later in our next sessions. And last but not least, chlorine is used in the manufacture of bleaching agents. Like sodium chlorate 1 is used in cotton and paper industries, and it is used to form or to make bleaches like jik. So if you are actually using jik, it contains sodium chlorate 1. This particular substance is used as a bleaching agent. Okay? Yeah. So in paper industries, we also use sodium chlorate 1, which is used for bleaching, hence making the paper to look very white. So, for those few and or more remarks, I think we shall end our lesson at that particular point. So we meet again in our next session so that we can talk about hydrogen chloride. Have a nice time. Bye-bye. See you later.